Good evening, everybody. Welcome to our session about how to create a great GitHub site. My name is Seema Iyer, and we are going to record this session. So if you want to keep your camera off, you can. And we will post this on our YouTube channel. And we're super excited to have Billy Daly here joining us today. So I'm Seema Iyer. I oversee the Baltimore Neighborhood Indicators Alliance. Welcome to everybody that is either here in Baltimore already or maybe coming from far away. We might have some of our friends from other cities that have similar projects like the Baltimore Neighborhood Indicators Alliance here in Baltimore. So we welcome you. We have a couple of things going on in the BINIA project, and then I'm going to turn it over to our Civic Engagement Fellow, Tamara, to introduce why we're doing this session. But if you don't know, we are working on a pretty major project called the Baltimore Community Change Project, and we are going to put that in the chat. We have many different events going on this month. We call it March Madness. We have neighborhood trivia. There's one tomorrow night. Please join us if you want to. And then we have a series of webinars next week on different topics related to neighborhood change. And then the final week, the following week, we have a series of convenings to help communities really think through different kinds of solutions based on what the data is showing us. So join us for all of upcoming events. You could be our best friends in March because you're going to spend the whole month with us. And that would be awesome. I'm going to turn it over to Tamar Buchanan, who was been with us from UMBC as our civic engagement fellow to really help BINIA better understand how we could be of more intentional purpose to civic technologists in Baltimore. I think we happened to figure out that we would be useful to civic technologists, but we kind of fell into that role rather than really thinking more strategically and maybe more proactively of how we could be engaged with civic technologists. So we might be coming at this from the opposite direction. We have a lot of resources and we want to know how we can use all those resources in a way that makes sense to all of you. So we're kind of making a translation here, and Billy's going to help us do that. But I'm going to turn over to Tamara, and thank you, Tamara, for hosting this session and all the work you've done with us so far.
Thank you, Seema, and thank you everyone for joining us today. I'm curious to know how everyone learned about the event, so feel free to drop that in the chat now if you want. My name is Tamar Buchanan, and I'm currently a fellow working with Baltimore Neighborhood Indicators Alliance, and I am a graduate student at the University of Maryland, Baltimore County, and the Healthcare Information Technology program. So as Seema mentioned, one of the main projects I've been working on is trying to better connect civic technologists in Baltimore with the organization and connect them with BINIA's data. And for the project, I interviewed over a dozen technologists in the area, one of which is Mr. Daly, who's speaking today. And from our conversation, I realized how important it is for us to have a well thought out GitHub repo, because the repo serves as a great way to document civic and community-based projects. And Billy is Baltimore's local GitHub guru. So in his current role as a data infrastructure lead for Baltimore City's Department of General Services, Billy works with both agency leadership and fellow analysts to improve how the agency stores, documents, and utilizes data to support service delivery. Much of this work depends on using GitHub to collaborate with stakeholders and manage project milestones. Billy has also contributed to a number of open source projects through which he's been introduced to innovative strategies for engaging communities of developers and volunteers around a common cause. So with that, I'll go ahead and turn it over to Billy.
Yeah, thank you so much. And thanks for having me here. It's really nice getting a chance to see folks who are also interested in learning about GitHub. It's a small but mighty contingent of folks here. So I'm glad to be a part of it with you all. So I'm gonna share my screen in just a second. But before I kind of do that, I just wanted to do like kind of a quick pulse check with the group to see how much about sort of GitHub and Git people are familiar with. And so feel free, if you want, to just like post it in the chat, kind of like what your experience is with GitHub, if you feel comfortable sharing that, and kind of what you were hoping to get out of this call. And what I'll do is I'll start sharing my screen, and then I will kind of pivot back to here just to kind of get a sense for what folks are hoping to get out of today's talk. So let me share my screen, and I'll start with the Google Chrome tab. This should hopefully get us there. Let me know, can you all see my screen okay? The perpetual question in this remote world that we're living in. All right, cool. Excellent. And then let me just pivot back to, it seems like the chat might have disappeared for me. Let's see if I can, oh, here we go. There's the chat. Okay, excellent. So it seems like folks are kind of familiar with using GitHub, or at least one person is. They might, but they might use Bitbucket as well. Okay, cool. So and some people have experience working on projects, but mostly only commit, push, and pull. Excellent. So it seems like it's good. This is good. It seems like we've got some kind of diversity of experience and perspectives, which is a good place to start. So what I might do is actually kind of just do a quick, before I jump into the full presentation, what I can do is kind of give like a quick background on Git for folks who might be a little bit newer to it, and then kind of jump into the conversation around what I was really hoping to cover mostly. So just to kind of quickly talk about Git, and like what it is and why it's useful, and then also talk about the difference between Git and GitHub. The way I often like to think about it, and I wish I should have probably put together a quick slide for this, but the way I like to think about it is Git is kind of like, imagine whenever you're working on, like, let's say a Word doc, and you're like, oh, I want to like change this one thing, but I kind of want to hang on to the previous version that I have. And so sometimes what you'll do is you'll save as, and then you'll kind of rename that new version and make some changes to it, and maybe go back to that original doc and pull some content if you've changed a lot of things. So Git is kind of a workflow based protocol that basically lets you do that a little bit more strategically, but with code. And so the idea behind Git, you'll hear me talk about this quite a bit in today's presentation, is that most of Git is kind of centered around these notions of commits, and these notions of branches. And the idea behind that is every time you sort of make a commit, that's sort of equivalent to hitting save, save on a Word doc, or if you've used Google Docs, it's kind of the equivalent of saying like, hey, I want to create a named version of this particular doc, so this way I can go back to that specific version if I want to. What's cool about Git, though, in particular, is that you can actually kind of work on multiple versions of the document, in this case, like your code, at the same time, and then work with other people who are also working on that doc, and then be able to kind of pull together the changes that you've made back into that main doc. And so that's kind of the idea behind a Git workflow, and I'll be talking a little bit more about them in today's meeting. But that's what Git is as a protocol and as a tool. And then GitHub is basically just it's a hosted version of the Git protocol. So think like in the same way that you have sort of, Word docs more broadly, but then you might have Google Docs, which is like sort of one way of interacting with those Word documents. GitHub is basically a place to store code and to use the Git protocol to manage versions of your code base and to collaborate with other people on that code. So that's a super simplistic high-level overview of Git and GitHub, but I wanted to kind of orient us around that before we sort of dive into talking about how to use GitHub to engage different communities of people around the code and the data that you're working with. And so, one other thing I'll mention too, as we're talking, is there's a lot to cover, obviously, but I really want us to be an interactive conversation. So I'll try to pause at sort of the different junctures that feel pretty natural to field questions. But if someone on the Beanie team wouldn't mind just like keeping an eye on the chat and letting me know if someone does have a question, or if folks feel comfortable just like unmuting themselves if there's something like particularly important to touch on or a question to ask, like when I'm on a particular slide, that would be great. But otherwise, yeah, we can definitely save some time at the end for questions. So the way I wanted to frame this conversation today is to kind of take a walk through what are the different steps that you can take to make your code base more accessible to a team or the public of external collaborators, people who would want to maybe use your code or contribute to your code or collaborate with you. And so the way I kind of want to frame that is 4 different things that a good code base should be. And we're going to kind of walk through these step by step. And the idea is that each one of these sort of builds on the previous one. And we'll talk about kind of how to sort of tie it all together at the end. But a good code base, as you can see here, should be understandable. And what that means is that users should be able to understand what your code does and how they can use it, right? So when you're coming to a code base or you're coming to a repository on GitHub, you want to understand, what is this code actually doing? How do I download it? How do I install it? How do I use it? And what would it actually help me do? The second thing it should be is reproducible. And what that means is that the classic sort of works on my machine, right? Sometimes you'll be working on your own code, and then let's say you push it up to GitHub, but if someone else wants to copy that code down to their own local computer, they should be able to run that code in the same way that you did without having to go through a bunch of hurdles to sort of fix bugs that pop up or install a bunch of packages, etc. So then, in addition to being understandable and reproducible, the third thing that a good code base should be is organized. And really the key here is that an organized code base is one in which opportunities to contribute are clearly defined and scoped. So folks who want to contribute to your code base understand, well, what's an issue that I can work on? Or is there a particular question that you haven't been able to answer that it would be helpful to get someone's support answering? Or is there a particular feature that I can add that you all would like? And how do I do that in a way that is additive and not confusing? And then the last thing that a code base should be, I mean, there's many things that a code base should be, but the last thing we'll talk about today is that a good code base should be reliable. And what that means is that even as you continue to make changes to your code base, like adding new features, or in the case of an example repo like Binya, as you kind of add indicators for a future year of vital signs, how do you make sure that the existing code base sort of remains stable and that it continues to behave the way that people who came to it before expect it to behave? So these are kind of the 4 things that we'll talk about today. And then what we'll do at the end of the talk is kind of look at a couple of example repos. One that is a project that I've kind of been working on. It's a pretty mature open source project. And then look at an example of one of Binya's GitHub repositories to kind of take a look and see, hey, does it do all these things? What are some of the ways that we can incorporate some of these best practices? Yeah, so I want to maybe pause there. Any quick questions about sort of what these things mean before we actually dive into talking about the tools that might help you achieve some of these best practices? All right. So with that, what we'll do is we'll start by talking about how code could be a little bit more understandable. And so what I want to do, and you'll notice this as we kind of go throughout the different sections, I like to start with a slide like this, which is talking about what are different tools that are available to make your code more whatever, right? So more understandable, more reliable, more reproducible. And the way that I wanted to frame this here is the items that are listed in number 1, these are kind of like the non-negotiables, right? Like every open source data repository or code repository should have these things. And then as we kind of look at the second and the third one, these are kind of ways of getting to the next tier of open source engagement, accessibility, etc. And so for understandable code, the 3 kind of tools that we have at our disposal are number 1, repository docs. And so those include things like a good README, a license, contributing guidelines, code of conduct, etc. And we'll talk on kind of subsequent slides about what are some good examples of things that should go in each of those documents. But that's really your first sort of line of defense to make code more accessible, is that the first thing you see when you go to a code base is the README. And are you making full use of that README? The second thing is within the code base itself, it's really great to have code comments and doc strings. And for folks who are kind of newer to coding, these might sound like foreign concepts, but basically this is ways of having inline documentation that explains how each class, method, or function behaves, how to use it, et cetera, et cetera. And then the last sort of thing, the last tool in the toolbox for making code more understandable, and this is again, not sort of an expectation that every single code base has this, but it's a way to kind of bring it to the next level around clarity and understanding and making code that's understandable, is having hosted docs and wikis. And so this might be, if you are working on a Python project, there's like the read the docs tool that's available. That could be using that, or having and making use of GitHub's wiki feature itself. So what I'm going to do is over the next couple slides, I'm going to talk about mostly these kind of first two items, and then I'll kind of link on a third slide. We won't go through them in depth, but I'll link to some additional resources that you can use to investigate further. So the first thing I want to talk about around understandable code is what are some good components that are commonly included in thorough or robust READMEs. And so this is by no means an exhaustive list, but when we look at a lot of really good repos, they usually include things in sections like this. And so that could be an about this project section. It could be a project roadmap, which might highlight additional features that are kind of coming down the line. Or it might include things like these features are ones that we don't ever anticipate to support. It typically has a license to let people know this is how you can engage with this code base, right? Is this an open source license? Is it one that sort of prohibits commercial use, or one that does permit commercial use, etc.? Then you also want to have a section around using the code. And so that would include things like, how do you set up the development environment and install the code base in order to actually run it? What are some common use cases and examples of how to use this code or work with this data if it's more of a data repository? And then also having links to further documentation. So that kind of goes back to what we were just talking about, right? If you have a hosted document, you can include it there. Another good component to have in a README is instructions on how to contribute, right? If part of what you're trying to do by open sourcing a project is sort of build your base of collaborators who are working on that with you, then you want to have contributing guidelines. You want to have a code of conduct that you want contributors to follow. So this way they're being kind of productive and they're productive members of the community that are aligning with your values. And then you also want to sort of link to bugs and features that individual contributors can work on. So this way they know where they can plug in. And one thing I just wanted to highlight quickly is this pro tip. And this might be old news to some people, but I found this really cool and didn't know it until I kind of started digging a little bit deeper in the GitHub documentation, is that you can actually have a README at every level of the directory, right? So if you have your repository, there's that first page, right? That's your README that first shows up when you go to your repository. But if you go into individual folders, you can also have READMEs in those folders. And then when you click into that folder, it'll be the first document that you see that kind of shows up. And that's a really helpful way. Let's say if you have a really complex code base, or maybe, for example, using like the vital signs repository, if you wanted to have different information about each year of vital signs, and that's kind of the way that the repository is structured, you can use a GitHub README at each of those levels to kind of have different information about each folder in that repository. And then this is a super, super high level overview of code comments. You could give a whole talk on code comments on its own. But what I wanted to do is kind of like orient people around how to think about putting in doc strings and code comments in their code base. And the way I really like to think about it is a good set of code comments answers three questions. The first thing that it answers is, what does this code do, right? So if you're looking at a code base and you're looking at, let's say, some Python code, the first thing you want to know is just like at a high level, what is this section of this code actually doing, or what is this function doing? The second thing is you want to know, how am I actually supposed to use it, right? Like, what types of variables can I pass to this code? Are there any restrictions, like which variables are optional, or which parameters are optional, which ones are required, etc. And then what's the format of the data that's returned, or the object that's returned by that particular function, method, or class. And then the third thing that's often important to highlight too is, why was this particular line of code or function or class implemented in this way? And so this is a particularly helpful comment to include if, say, like you ran into a bug and you found a solution to it on Stack Exchange, and you had to kind of put in a workaround. It's often good to say, hey, I ran into this bug, here was my workaround, and then link to that particular Stack Exchange issue, right? So this way, a future developer who's coming across your code base knows why you took that particular path. And so, like I said, I won't dive into this really in depth, but what I can do is I'll share the links to these slides at the end of the presentation in the chat. And this way, if you want to dive deeper into these sections, you can do that. So I already know that was already a lot of info just on how to make code understandable. Hopefully the information itself was understandable. But I also wanted to kind of pause here really quickly just to see if folks had questions or wanted me to dive a little bit deeper into any of the things that I talked about in the last section before I kind of go on to this next one. All right. Yeah, definitely don't hesitate to unmute yourself if you do have questions, but I'm glad, hopefully no questions means that I'm covering the material in a way that's understandable. But yeah, we can kind of dive in a little bit further. All right, so the next section is making code reproducible. As I mentioned, right, reproducibility is all about, can the code that worked on your machine also work on my machine? And there are really three core things that I think contribute to having really reproducible code. The first one is dependency management. And so what this means is a lot of times when you're writing code, you're not writing everything from scratch. You're kind of borrowing the functionality of packages or other code bases to kind of do what you're trying to do. So for example, if you're crunching numbers, you might use pandas or NumPy. And so someone who wants to run your code would also need NumPy or pandas installed on their machine. And so the first step is really just making sure that all of the packages and dependencies that you use to run your code are listed in the code base. This way someone else can install them themselves and make sure that they can run your code successfully. The second thing that you'll want is, it's not just enough to have a listing of those packages. You'll also want some guidance on saying, hey, before you can install these packages, you need to have this version of Python installed on your computer, or you need to have, this other helper package set up. And sometimes those could be things like outside of Python. If your code is in Python, those might be like a C package that you need kind of pre-installed. Usually they're really more around like the language itself, right? What version of Python or what version of JavaScript you're using. But you want to sort of help people figure out, how do I actually get this list of packages that you list in your code base installed on my computer and working in a way that doesn't conflict with the other packages I have installed on my computer. And then the last step, as I mentioned, this is kind of like, gold standard, is using something called containerization. And this is a way of kind of packaging up all those dependencies and all of the prerequisites, and sometimes even like sort of a lightweight OS operating system into a file that you can just use to like hit one, either one command in the command line or one button, and it would just immediately install and set up all the infrastructure that you really need to run your code base. And we won't go into that in depth because it's a little bit complicated, but it's another one of those resources that I kind of linked to in the resources section of this particular portion of the presentation. So the first thing I really want to do is, like, rather than diving into like specific tools to do all these things, is just kind of zoom out and actually talk about like, why do development environments matter? And I don't know if there's any XKCD fans on this particular meeting, but I really love XKCD, and I think this particular comic captures why I love Python so much, and why Randall, I forget what Randall, whoever the guy behind XKCD, like why he likes Python. So you can see here the image is of this person flying, and the person on the ground says, you're flying, how? And the person says Python. And basically they're just saying Python's super easy because you could just import a bunch of packages and they just do things for you, right? And so when we're talking about using, and especially working with Python, what's great about it is that, as I mentioned, you don't have to write all these different things from scratch. You can kind of borrow the functionality of existing packages and libraries that other people have created. But one of the challenges of working with Python in particular is that Python dependency management is a nightmare, especially if you just kind of like do pip install blindly on your computer. You can wind up with what people sometimes call dependency hell. And the sort of subtext for this particular comic is, my Python environment has become so degraded that my laptop has been declared a Superfund site. And so I don't know if other people have encountered this, but I've definitely encountered it, where I'm like, we'll install two different packages and then actually they have conflicting dependencies, and you're like, what the heck happened? I just followed the instructions on this GitHub repo to install everything I needed. Why is it breaking? And the short answer is installation environments or development environments. And so just to kind of give you a little bit more of a direct sense of like what's actually happening when you wind up in a scenario like this, what I want to do is kind of just show you a simple example. So let's say you have two different Python projects. And one of them requires you to use this library network X, and then another one requires you to use pandas. If you're just sort of blindly installing these projects on your computer, as is often pretty common and pretty understandable to do, just because you're following instructions on GitHub, what could happen is that you install pandas, and that kind of came packaged with this version of NumPy, which is just a different library that pandas depends on. And then you went to install network X, which also depends on NumPy. But the problem is that the version of NumPy that network X depends on is actually a different version than the one that was installed when you installed pandas. And so what happens is you kind of run into this situation in which you're like, hey, I can't actually install network X because it has the wrong version of NumPy installed. And this happens if you just blindly install everything, what sometimes people call at root. And so the way around it is to actually isolate your installations on your computer. And this is a super simplistic way of doing it. But one way to think about it is basically everything on your computer, packages, code, etc., is just a series of files and text. And so one way to think about sort of isolated installation environments is just like, you're basically just creating multiple copies of Python versions and the supporting code base every time you're starting a new project. And this is actually really important to make sure that your installations and your different versions of packages that you're using don't conflict with one another. And I know that's like, this again could be its own full talk, just like talking about sort of how to manage multiple different dependencies and versions of Python. But the reason I really wanted to highlight it is because, and I'll kind of show you what this looks like in a GitHub repo. What's super important in your GitHub repo is to say, hey, here's all the packages that that are required to run this code, and here's how to install these packages in a way that won't conflict with any other projects that you have. And some of the tools that are used to do that are listed here on this additional resources. But the main ones are, so pip is just like used to install information or packages more broadly, but pipenv and poetry are two really great tools in the Python ecosystem that allow you to install multiple kind of dependencies concurrently and just manage package dependencies really easily. There's also this whole notion of like virtual environments, which is what I have a link to down here. And so again, each of these things has a ton of depth, which is why, I think it's good. It might just be good to kind of link to some of these documentations and do a deeper dive when folks are interested, because you don't need to know all this stuff out of the gate. But one thing I think, if you take nothing away from this talk, the one thing is make sure you list using a requirements.txt file, make sure you list what requirements, if you're using Python, make sure you list what requirements are needed in order to run your code. That's like, if you take nothing away, make sure you do that. And then if you can, try to use a virtual environment to install those packages so you don't run into this situation on your own computer. Okay, I know we're kind of going through this at a really fast clip, but part of it is because I actually want to be able to pivot to a GitHub repository itself to actually kind of look at some of these things in practice. But any questions so far on what I've covered? I know we're kind of staying at a pretty high level, which is sort of by design, because I want to kind of dive into the code itself as an example. But any questions about what we've covered so far? All right, y'all are picking this up really quickly, which is hopefully good. Either that or I'm like, I've lost everybody, and hopefully it's not the latter. All right, so the next thing I'm going to be talking about is how to actually organize your code base. And so there's a bunch of different tools that are available to do this. But I really want to talk about kind of three in particular. And again, like the other sections, these different tools build one on top of the other. So every single code base, where possible, should try to make use of issues and branching. And then if you have time and capacity, it's good to try to make use of labels, projects, and milestones. And then if you really want to go above and beyond, you can use templates. But I want to sort of start by talking about issues and branching. So as you can see here, issues and branching or an organized code base is one where contributions to your code base follow consistent Git workflows that utilizes issues and branching. And so that's a lot of different words that are all kind of specific to GitHub. But what that basically means is that in GitHub, there's ways of defining things that you still need to do to your code base. And that could be if there's a bug in your code, right? So someone tries to run your code, and something that they think they should be able to do, or something that you told them they would be able to do, they're not actually able to do. And that could be because either it wasn't designed correctly, or there's actually just like they're testing your code on an edge case that you didn't handle before. That's an example of a bug. And so an issue, one way of using an issue is to say, hey, I was trying to do this thing and it didn't work. And so I'm reporting that there's a bug in this code. Another type of issue that's really common is, let's say someone's using your code base and they really like what you're doing, and they say, hey, I want to do something else. Can you actually add this feature? So that's like another type of issue. And then branches, as I mentioned, branches are basically a way of saying, we've got this main portion of the code base that has kind of the live production code that we know is stable. And then we want to work temporarily on this sort of side project that we eventually might want to pull back into that main code base, but we want to do it in a way that's kind of safe and doesn't potentially disrupt the core code base that other people are using. And so what you do is you create a branch, and then you kind of work on that code base. And then Git has this notion of what's called merging. And merging is basically saying, hey, I've done all this work on this branch, and I want you to pull that back into the main sort of code trunk, which is kind of where the term branching comes from, right? So that's kind of issues and branching. And there's a bunch of different ways of kind of utilizing issues and using branches. And that sort of combination of issues and branches together represent what's often called a Git workflow, which is like, what do you name your branches? How do you use issues in relation to them, et cetera? And so that's like your best tool for organizing your code base. The second thing that you can do once you have issues and branching is you can start applying labels to those issues. And then you can start organizing them into projects or milestones. And I'll talk a little bit about what those things are on the subsequent slides. But one thing to take away, as you can see here, is that an organized code base is one in which outstanding issues are organized into labels. So this way folks can like look for issues that are related to a particular topic, or they can filter for issues where there's help wanted, or something like that, or like filter just for bugs. And then those issues are tracked via projects or milestones. And then the last thing that we'll kind of touch on, and I'll mostly just talk about it at a high level, I won't actually have like a slide for it, is you can use, GitHub allows you to have templates for issues and templates for pull requests. And what those are is basically they're kind of ways of pre-populating interfaces on GitHub. So this way, when you're submitting a new request, you actually have some helper text that will kind of populate on the page. And that makes it a little bit easier to kind of guide people to fill out the details that you want. And so what we're going to be talking about a little bit in this next slide is, well, what are those details that you would want people to capture when they're either submitting a new issue or submitting a pull request? And I don't know if I talked about this directly, but a pull request is basically when you have work on a branch and you want someone to pull it back into the main trunk of the repository, then what you're doing is you're saying, hey, I'm issuing a pull request, which is asking that you pull this code back into the kind of working stable version of the code base. So that's kind of what a pull request is. But in a bug report, the things you'd want to have are, so if someone's saying, hey, I encountered this issue, the first thing you'd want to do is have them detail out, well, what are the actual steps that I need to take in order to reproduce the issue that you encountered? Because a lot of times you can't actually fix an issue until you can reproduce it yourself. The second thing that you want to do is have them explain, well, this is the expected behavior this is the behavior of the code base that I expected. And here's how the actual thing that I did when I followed these steps differed from that expectation. And the reason it's important to talk about this is because sometimes there's just misalignment on what the expected behavior is. And so understanding what the person expected the behavior to be helps you then diagnose the real issue. And then the last thing is, and this kind of goes back a little bit to this development environment question, which is you want to understand, well, what environment do they have set up on their computer? So if it's code that's just kind of running on their own machine locally, you want to understand what version of the Python are they using, what types of packages do they have installed in their pip environment. If it's something that's running in the browser, you might want to know what browser are they using. Is it Chrome or Safari or Mozilla? Maybe what operating system they're using. So those are kind of all the details you want to know in order to help you diagnose an issue or a bug with the code. If they're requesting a new feature, then what you might want to do is start with asking them, either you define or asking them to define a user story. And so a lot of times this takes the shape of, as a blank, I want to do blank so that blank, right? So like as a developer, I want to be able to click a button or write one command and have the code automatically installed with all the dependencies that it needed to, so that I don't accidentally install the wrong version of a package, right? That's like an example of the user story. You also want to know what existing alternatives did they consider that kind of help you avoid or circumvent having to create a new feature. And then what's your definition of done, right? Like what's sort of a minimum viable product that you could deliver that would satisfy this user story, and that would surpass some of the other alternatives that they considered. And then let's say you're asking a contributor to actually submit a new request like that kind of fixes, or some new code that fixes this bug or adds this new feature. One of the things that some of the things you'll want them to include is what issue are they referencing? Is there what issue is their code helping address, right? So that kind of goes like, let's point to a specific issue here or here. What changes do they actually introduce in their code base, right? Like what new features are added, or what previous behavior did they change or amend? And then kind of providing some instructions, like this is how you can actually test to make sure that this code is working, right? And so the last thing I'll kind of highlight on this slide is one of the cool things that I mentioned on the previous slide is that GitHub allows you to create unique templates for different types of issues. And so if you wanted to have an issue type that's specifically bug report, you can have that populate with a different set of guidelines than if you were to create a feature request issue. It can kind of populate with different content. Oh yes, Tamara, I see that. Tamara, I see that you raised your hand.
I just noticed that Erica in the chat has a question.
Oh, perfect. Sorry. What? Let me see. I don't know if I see the chat. Okay, let's see. The chat says, would you also expect the same kind of details when reporting issues on data, not on code repositories? Ooh, that's a good question. Yeah. So I definitely, my background is a little bit more in engineering. What I would say, if we go back to this previous slide here, let's see. Oops. Let's go back to this previous slide. So what I would say is, like, let's say you're reporting out on data. You might not have like a bug report in the same way, because it's not like the code is trying to behave a certain way. But if you notice that, like, oh, there's a problem in the analysis, then you might not have steps to reproduce, but you would probably definitely have sort of an expected behavior that you'd have people talk about, like where this is what I think this code should be, and here's why this is different. Especially if you're kind of using this data for analysis and you're trying to rederive the results that are kind of stored in that data, then what you might want to do is say, here's the steps that I took to recalculate or retabulate this particular metric, and I'm getting a different answer than what you have in the in the repository itself. So they're definitely not a one-to-one mapping. If it's a data repository, it would be a little bit different. But I think, like, the general gist, right, is what you're really trying to get people to articulate when they're reporting issues, or if you yourself are reporting an issue, is this is what I expected to happen, and this is why it's different. Or if it's a feature request, like, here's what I want to happen, and here's what you could add, either from a data perspective or from a code functionality perspective. Here's what you could add that would actually satisfy this expectation or this sort of desire that I have. So I don't know. I know that's maybe not a perfect answer, but hopefully does that kind of speak to it a little bit? Yeah. That's a great way to kind of distill that is you want to sort of tell the story of what you're expecting, and tell the story of how it's what you're seeing or what you're engaging with is different from what you're expecting. Okay, let's so then I'll kind of quickly just highlight this real quick. It looks like, oh wait, sorry, Eric. Yeah, thank you. If I misstated that my bad. So what I kind of quickly want to do, just touch on this before we go into the next section is to talk about projects versus milestones. Folks who have experience with GitHub might have kind of heard about both of these things. I know I myself was kind of confused about the distinction between these and kind of when to use each. What I would say is that at a high level, projects are kind of organized. Some of the benefits of projects are that they allow you to organize issues in multiple different formats. So you can either do it in like a Kanban style. So that's like having those kind of columns and having cards kind of move between the columns. That's a Kanban format. And then they also recently, GitHub released a feature where you can actually now view issues as lists and kind of, categorize them based on tag or based on the person they're assigned to, et cetera. So what's great about projects is they let you visualize issues in lots of different ways and kind of track. And as you'll notice here, they allow you to sort of track issues based on the stage that they're in or the label that they have. Some of the cons around it are that a lot of the features are still in beta version, as I was mentioning, and it doesn't support currently deadlines or due dates. So like if you wanted to say, hey, this particular feature request needs to be added or this bug needs to be fixed by 2 weeks from now, like you can't do that via projects. Whereas milestones, these are really more of the due date, kind of a deadline oriented feature. So this allows you to say, hey, all these issues, we want to achieve them all by this date, and they all kind of have the same common deliverable that they're related to. And the one thing that's sort of a con around using milestones are that issues can only be associated with one milestone at a time. Whereas with projects, like one issue can be associated with multiple projects. So let's say if you wanted to track, bugs, all the bugs in one project, but you also wanted to have another project that was like more oriented around like the kinds of work, right? Like then you could have an issue beyond both, whereas a milestone, you could only have one deadline associated with a given issue at a time. So I would say kind of like zooming out a little bit, I would use projects to track and communicate the status of outstanding bugs and feature requests. Like, so this is really more about like watching an issue or request move through a pipeline and sort of understand where it is in that pipeline. Whereas milestones are better for, organizing issues or deliverables around deadlines or timelines. So that's kind of the core difference between those two. And then this one, I haven't gotten a chance yet to kind of finish linking stuff, but these are some of the topics that I'll be linking in. So you'll see, like when I share the links to these slides, I'll continue to add. So this way we can make sure we have resources for each of them. How are we doing on time? Oh, we are getting close. So yeah, I might, if it's okay, I might kind of try to breeze through this last part. This is super, super important. So I hate to shortchange this section, but I do want to kind of pivot to some actual examples of repositories to show you all. So the last thing I want to touch on is we want, in addition to our code bases being understandable, reproducible, and organized, we also really want them to be reliable. And I kind of going back to this question, like we want this to be true both for data repositories as well as code repositories. And so what this means is, or some of the features and tools that allow us to make code reliable is to have good test coverage. And so what that means is to have all your critical classes, methods, and functions, or if we're talking about data repositories, right, like the calculations that actually produce the data in that, we want them to be covered by what are called unit tests, which is basically just like your way of saying this code is actually calculating this metric in the way that we say it's calculating this metric. And we want those unit tests to be passing. The other thing you want is to have code quality checks. And so, oh wait, I forgot to change this. I can fix that. But basically, code quality checks are basically your ways of making sure that like the code meets certain standards or kind of best practices. And then tags and releases, this is a way of sort of organizing how you are sort of segmenting changes to the code base. So this way, I don't know if folks have ever used, like packages like pandas, and when you say, hey, import or install pandas version, 1.4.3, that's like sort of pegging that version of pandas at that point in time. And this way, anytime you're running and using that version of pandas, you know that it will continue to behave the way that it did when the code was sort of written at that point in time. And so it's like a way of kind of providing stability of your code base. And And so first I wanted to do is just talk about tests. I could talk again at length about tests. I think test coverage and unit testing is really important, but I wanted to sort of talk about why it's really important to add testing to your repositories. So the first thing is that they ensure that changes made to the code base don't break existing functionality. So let's say you wanted to add a new metric to the vital signs report, and that you want to sort of tweak the way that you were calculating it. You had some sort of common function that was used across multiple metrics. If you tweak that function, it might actually change the result of the metric of one of the other indicators. And so what you want to do is you want to have unit tests set up. So this way, if you change one particular function that's shared across multiple different sections of the code base, those other tests will break, right? And so this way you'll know, oh, if I change this here, it's also going to have implications on these other sections. The other thing that testing does is it helps you explicitly define sort of the behavior and the expectations of the code base, and new features that you're proposing. And then the last thing is it helps you, like, let's say if someone reports a bug or an issue, what you can do is you can create like a little mini sort of toy example that reproduces that bug, and then you can write code that specifically addresses that particular issue. And because you've written a test for it, and like you're running that every time you sort of check out the code base, you'll know that like that code still fixes that issue or still has a workaround for that issue. And then quickly, I'll touch on some common code quality checks. So the big one is often formatting. And so this is basically like ways of kind of reformatting or restructuring your code base to make sure that like the code is written consistently and follows a style guide. The second is around linting. And so this basically makes sure that like you're not introducing things that could introduce bugs later on. And so Python in particular has a really strong style guide and some really strong guidelines around, this is how a function should be defined. You should import packages in this order, et cetera. And so that's really what linting is sort of focused on. And then the last really important one to touch on is like security checks. And so because a lot of code often depends on a bunch of different packages or other libraries, security scanning is really important, because if there's like a known vulnerability in some version of, again, just using pandas as kind of an example, if there's some issue or some vulnerability in pandas, and your code depends on that version of pandas, you want to know, so this way you can bump that version and kind of use the next stable, secure version of pandas. And so these are, again, I'll kind of link in some more test coverage here. But the last thing I want to do is just kind of talk about, we've talked about a bunch of different tools that we can use here, and we didn't really go into depth with a lot of them. And so what I want to do is just kind of talk about how to think about adopting these practices for your own code base. And so what I would do is kind of think about it this way, right? First, what you want to do is you want to build, vertically. You want to start by building on these foundations. So kind of move up in terms of adding these features. And then once you've covered the full pipeline, then what you can start doing is you can start moving over, right? So first you want to have good repo docs, then you want to have good dependency management, you want to use issues and branching, and you want to have basic test coverage. And then you can come back down and I mean, it's not like strictly this order, but you don't want to sort of start using tags and releases before you have basic code quality checks, or you don't want to focus on containerization before you have coded comments and doc strings. So you kind of want to generally move up and then over. And so what we're going to do is we're going to kind of focus on two core code bases that I think do a really great job of incorporating a lot of these practices. The first one, and I forgot to link them in, but I'll do that. The first one is this USDS Justice 40 tool. So this is actually one that I've used quite a bit and contributed to a fair amount. So this is like a project. And the first thing I want to note here is they've got a really robust README, which is great, right? So you can sort of see here, they've got some background on the project. They have a description of how to engage. They have some guidelines for contributions. And they kind of have, you can see here, different ways to quickly plug in depending on how you're encountering this particular repository. The other thing that they have, and I'll just kind of quickly click on it, is they have an actual link to some external documentation and to the tool itself, which is really cool. And so if we go back up here, let me just hide this video really quick. so you can see here, they have some external documentation as well. And what I want to quickly do is go back and kind of look at, so this is what I was talking about around, using issues really effectively. You'll notice here, this is an example of kind of like a feature request or like a new, new use case that they want to address. And right in the title here, they have an example of a user story, right? So as a data developer, I want to understand different mathematical approaches for converting between census tract and other geographic units, so that I can understand their pros and cons. And then they kind of have, description. This is a pretty brief description of just sort of like, hey, here's what a, definition of done or like a minimum viable product kind of thing would look like. And what you can do is, let's say if you wanted to just focus on the data ones, you can kind of filter based on that. You can also, let's say if I was an open source contributor and I wanted to specifically focus on the help wanted ones, I can go and I could look, oh, these are all the different issues that they're asking for help on. And then I know this is like a lightning fast tour through all this stuff, but what I want to do kind of quickly was show you some of the automated testing that they have set up. So if you go in here, you can see this is this thing called GitHub Actions, basically, and each of these run a series of code quality checks or unit tests to make sure that, like, when someone is contributing new code, they're not breaking the code base, right? And so you can see here it's sort of saying, hey, this was successfully was able to calculate the score, and it was successfully able to rebuild the map, essentially. So this way they make sure they're not kind of breaking the code base as they add new features. And so the last thing, maybe what we can do is I'll kind of just pull up, so this way we'll have it for reference, and then we can kind of field questions, is I wanted to pull open Binya's vital signs repository, kind of as a way of saying, hey, let's come back to an example of Binya's repository and see, like, which of these kind of best practices have we already adopted, and where might there be some additional areas for growth, to sort of pull stuff in. And one thing that I'll kind of highlight is that y'all have, the Binya team has a great README, right? There's some really great descriptions of, right, around, like, what is this code doing? They've got some really awesome kind of tools here to sort of show you, like, what versions of Python it supports, when did they last commit to it. You can open it in Colab. So already they're doing a lot of really great stuff. And they've got some instructions for how to actually install the package. And from a containerization standpoint, I know this is not using Docker, which is a common container solution, but it is deployed to PyPy. And so that's an easy way to actually just install all this code, and have it working ready. So yeah, I know that's already been a lot of info, and we're probably close to the end of time, but I wanted to kind of leave some room for questions, or for us to kind of like walk through this repository together if there are, like, specific things that folks wanted to highlight or ask about around how to kind of make this a little bit more robust and make it easier for folks to engage with this repository. And actually, let me look at the chat to see. Okay, it looks like there was. Oh, perfect. It just says, thank you, Seema, for letting me talk about this stuff. I know this is a bit of drinking from a fire hose, just because there's so much to kind of talk about. Let me maybe I can kind of push this back to the team or to the group here. For folks who are using GitHub on a regular basis, what are some things, like, when you go to a repository, what are some things that, like, you find really helpful, either getting oriented with a particular repository or figuring out how you can kind of plug in? Are there any things that you personally have found really helpful? Let's see. Yeah, so testing, I'm a big fan of testing, just because I think it's often one of those things where it's like, it's easy to overlook until you do something that breaks everything, and then you're like, oh shoot, how do I go back and fix everything, right? Or, like, how do I know what broke when I push this change? Honestly, like, there's a whole framework around test-driven development, and it's actually one of the if I go back to my presentation. It's one of the resources I linked here at the end. This overview of test-driven development that I would like highly recommend everyone take a look at, because it's a totally different way of thinking about how to approach programming, where instead of starting by just writing code and then thinking about, okay, is this doing everything that I expected to do? What you start by doing is saying, this is how I expect this code to behave. You then write a test to check for that behavior. The test should fail because you haven't yet implemented it. And then what you do is then you implement the code that fixes the failing test. And so it's a really different way of thinking about coding, but it's a really strong way to make sure that like the code is doing exactly what you expect it to do. And it's especially helpful when you're working with data, because sometimes it's really easy to just like run a bunch of commands or formulas or do a bunch of stuff to a data frame and think that it's doing what you expect it to do, but actually like you've kind of missed something in the pandas documentation, and it's not grouping by the field that you thought it was grouping by, or it's transforming it in a way that you didn't expect. So I find testing really helpful on that front. Yeah, clean and clear commits. That's a really good point too, Eric. Oh yeah, and Dexter has some good points around documentation. Kind of having some good summaries. On the commit note, one thing that I did want to kind of drop, I think I have it in the repository, but I want to kind of call it out specifically here, is this, I've really liked it as a framework to kind of adopt myself. There's this thing called conventional commits. And this is like a way of kind of clearly conveying, this is what's happening in this particular commit. I just posted it into the chat. And so it's a way of saying like, hey, in this particular commit, I'm adding a new feature, or I'm fixing a bug, or I'm refactoring the code. And there's some like shorthand ways of saying like, this is a breaking change, meaning that when I push this new code, something that used to work a certain way will no longer work that way once we merge this back into like the main branch. And so I find it like a really powerful tool for kind of communicating the intentions of what you're doing in a particular commit. Yeah, so these are really great. I love some of what people have already posted into the chat. I'm kind of curious, like for folks, especially I know Eric, you've kind of been asking some questions about this. I kind of come, as I mentioned, more from an engineering background. And so that's what most of my experience in terms of using GitHub has been. For folks who use it to kind of like share or store or use data from other people, are there things that sort of feel different in terms of like the use of GitHub? Like do you find different things helpful in repositories that have a lot of data as opposed to repositories that have and are focused around like code? I know maybe one example. I think actually this project that I was highlighting. Oh yeah, I see. So Eric has this question around, curious about that too. We only store code and docs. Yeah, so I think I think like one example, and actually this is I think there's some differences in opinion around how to use GitHub effectively. Like some sort of engineering purists will say that like basically outside of test data, like you really shouldn't use GitHub as a data storage platform. And actually, I think like one of the reasons I liked this Justice 40 tool project as an example is because there is a really strong data component to this particular tool. But what this particular code base is really focused on is helping you basically get the code stored on your own machine. And part of the reason they do that is because the data sets that they're working with are like literally like hundreds of thousands, if not millions of lines of data, because they're dealing with census tracts and census block groups. And they're dealing with it for the whole country, as opposed to the whole country and US territories, as opposed to like a specific state or city. And so what they're really focused on doing is like basically helping build what are sometimes called ETL pipelines, which is extract, transform, and load pipelines, that helps people get data from existing sources, transform that data, and then get it downloaded as CSVs on their own computers. But what they also make available, since they recognize that not everyone would have the ability to kind of run that themselves, is they have the ability to sort of get hosted versions of the CSV and download individual ones that you're interested in. And they use that by sort of having in this code base, having the data get pushed to an S3 bucket. So like an Amazon, S3 bucket. So basically just like flat file storage essentially. And so that's like their way of kind of striking that balance of saying, hey, sometimes we want just like the code to be generally available to people without having to run a bunch of code on their own machine. But at the same time, we don't want to like overload this GitHub repo with like, gigabytes of data. And so what we're going to do is we're going to like use a repo to point to an existing place where they can download that repository or that data, and then also include all of the data that it's used to actually generate those flat files that are then stored on that S3 bucket. So I think it's like a good way of kind of striking that balance. Cool. And I know we are at time. Sorry for talking for so long. I can maybe stop sharing my screen. Let's stop my share. And then what I'll do is I'll also link to the slide decks that I was mentioning. So this way, if folks want to go back and reference it. And as I mentioned, I'll link to some additional resources that I was referencing in the presentation to make sure that you all can kind of go back and use that as a stable reference.